Joining us today on Superheroes of Science, we're excited to welcome Jill Newton, Associate Professor of Mathematics Education here at Purdue University. So welcome, Jill.
Well, thank you so much, Sarah and Steve, and I'm very happy to be here with you. I'm going to start with telling you a bit about who I am.
Fair enough.
So who am I? So formally, I'm Jill Newton. As Sarah mentioned, I'm an Associate Professor in Mathematics Education at Purdue University. But who am I really? I'm really Jill. I'm a teacher and a learner. I'm a traveler. I'm a sister, an aunt, a friend, and many other things. And I'm a mathematician. In this presentation, I'm going to talk through where I've been and the things that I've done, what I do now, what mathematics is to me and why it's important and why I love it, and who is a mathematician, as well as a few other things I think it's important to talk about whenever you talk about mathematics. So a little bit about me. I was born in Michigan and I went to school and college in Michigan. And I also went to college in Washington, D.C. at George Washington University. And then one year I was really lucky because my family used to always camp around the United States. And I was so lucky because I had the opportunity all by myself. I drove all the way around the United States in a year, camping and visiting friends and just enjoying this beautiful country in which we live.
Oh, wow.
So I was a math teacher for about 12 years, but most of that teaching I did overseas. And I say this because I want you to know that even when you think about being a math teacher, there are lots of different ways and directions you can take that career. So I started as a Peace Corps volunteer in Papua New Guinea, which is just north of Australia. It's a small island. And if you Google Papua New Guinea, these are the kinds of pictures that you'll find. The mudmen, the tribal warriors, the women in grass skirts, and the bird of paradise. But this is really not PNG. This is PNG. So when I taught in Papua New Guinea, these were the students that I taught in my first class. They were in 8th grade, and they're actually much more like you than they are like the people we just saw in those pictures. One thing that's really interesting mathematically about Papua New Guinea is that there's a tribe that has a base 27 counting system. And so unlike us who count with 10 fingers, and that is where our base 10 system is founded, they have a base 27 counting system. So instead of using their hands, they use their whole body to upper body, and they count starting with the thumb on this hand, going all the way to the small finger on the other hand, and they go all the way around, including up over the head, and they count 27 using that system. I also taught overseas in 2 countries in Africa. I taught in the Democratic Republic of Congo, which used to be called Zaire, as well as Tanzania, which they're both in Central Africa. I still go to Tanzania every year, and here's one of my students, Evan, with his class of students in Tanzania. One of the really interesting things mathematically in Africa are what are called fractals. So fractals, for those of you who don't know, if you think of a fractal really as a tree and how a tree branches, and each branch branches, and each branch branches, and so on, and each part of it is the same as the part before, but it gets smaller and smaller and smaller, and this tree is a nice example of a fractal. Well, in Africa, you see fractals play out in many different ways. For example, villages are built in fractal configurations, and actually very beautiful fractal configurations. Women's braids in their hair are often with fractal configurations, as well as a lot of the art in Africa, they use fractal configurations. So this is a really beautiful mathematical thing that's found both in nature, but also in lots of man-made structures. I also taught in Bulgaria for 2 years. Bulgaria is in Central Europe. And what I loved most about Bulgaria are all of the really rich traditions. One of my favorite traditions in Bulgaria was the what they call Chestita Baba Marta, which is in the picture there, the red and white things on the left. And on March 1st, everybody in Bulgaria gives each other these little red and white things, which you then tie on a tree when you see your first stork, and that's how they welcome spring. So this is just a beautiful tradition. Math in Bulgaria is really interesting. Bulgarians are known as this just amazing math, lots of amazing mathematicians. And Bulgaria is really interesting because everyone in Bulgaria thinks they're good at math. Being good in math is like being able to read. You don't hear Bulgarians who say, oh, I'm so bad at math. People don't say that. Bulgarians, there's an assumption in the culture that everyone can do math, which is not always the assumption in our culture, sadly. One of the things in Bulgaria is by the time you get to grade 9, almost all of the numbers have disappeared from mathematics. So it's almost completely theoretical, even by the time you're in 9th grade. The final place that I taught overseas was in Venezuela. And then after teaching in Venezuela, I came back to the United States and got my PhD at Michigan State, and then came to Purdue, where I've been for 13 years. So what do I do now? So as a professor, I have lots of different jobs. I do lots of different things. And of course, being a professor is another possible mathematics career as well. So mostly I teach teachers. I teach people who will be math teachers, but I also travel to Tanzania every spring with a group of Purdue students. And I also do lots of mentoring and collaborating and research, and the job of a professor is really multifaceted. So there's a lot going on, which I think is what makes it such interesting work. So I want to make a little analogy here, and I want to compare math to track and field. I feel like math is like track and field in a lot of ways. So if you've ever been to a track meet, maybe at your school, you've seen the 100-meter dash. And the 100-meter dash is like supposedly the best, the most important race. It's how we determine who's the fastest person in the world, which has become a really big thing. You can see here these 3 women, they're running the 100-meter dash. But I think if you went to a track meet and the only thing that was in the track meet was the 100-meter dash, it would hardly be worth going, because you would be there probably for about 20 seconds and you would go home. But what makes a track meet so interesting is that it's not just the 100-meter dash, it's lots of other things. For example, we have what we call relay races, where we put a bunch of people together in groups of 4 and they race against each other. We have another race where people run, but now we put hurdles so that they have to run and jump over things as they run. We have something where you run as fast as you can and then you jump as far as you can, which is called the long jump. We have another thing where you run and jump, but this time over a bar. We have something where you throw a bar, the javelin throwing. We also have where you throw other things like the discus, or in this case, the shot put. What's amazing and most exciting, though, about these track meets is that everyone doesn't do everything, and everyone can't be good at everything. This man who you see throwing this shot put, he's not going to be the marathoner. He's not going to be the long jumper. He's going to find the thing he's really good at and he enjoys, and he's going to do that thing. And what makes me sad in mathematics sometimes is we think math is just the 100-meter dash. We think math is just who can do their times tables the fastest and who can solve equations the fastest. And that is just this very, very small piece of mathematics. And mathematics is so much richer than that. And I think sometimes we lose sight of that. So mathematics, for sure, mathematics is numbers, right? And arithmetic. This is, of course, a really important part of mathematics. And all cultures everywhere in the world do this kind of mathematics. But there's also algebra. There's also geometry. Some people love geometry, but they don't really like algebra. Some people love statistics and probability, and that's what they think they're really good at and what they think is important, and that's what they spend their life doing. Other people like number theory and how numbers fit together. Other people like applied mathematics and combinatorics and even topology. And what's exciting about it is that you don't have to be good at all of these things, and you don't even have to like all of these things, but you can find your place. You find your own place in mathematics. And because mathematics has so many different areas, there's a place in this for everyone. What can you do? If you love mathematics, you enjoy mathematics, what are the things that you can do with that? Well, of course, you can be a mathematician, but that's just one little option. You could be an auditor or a cryptographer or a statistician, an accountant, a computer programmer, a financial planner, a data scientist, economist, a systems engineer, an actuary, an investment analyst, an operations research analyst, and lots, infinitely, another math word, infinitely many other possibilities for you if you enjoy math. Another thing about math that's really important is that it's used to solve problems, all kinds of problems, global and local problems. So for example, climate change and global warming and poverty and wildlife conservation and pandemics and getting clean drinking water to everyone in the world. All of those problems are solved using lots of different things, but mathematics is part of solving all of those problems. So if you're interested in mathematics, you can do any of those jobs. You can solve world problems. There's, again, always a place in mathematics for you. So what does a mathematician look like? Who can be a mathematician? When I started in advanced mathematics courses at Michigan State when I was in college, no one in my advanced classes looked like me. And so, of course, then there are times where you wonder, is this really something, that I can do? Is this something where I fit? And as you're in it for a while, you get, of course, more and more confident. But traditionally, historically, this is what mathematicians looked like. And of course, it's normal then that some of us wouldn't feel like we fit, because I certainly don't look like any of those people. These people were great mathematicians, no doubt about it. But there were also lots of other great mathematicians, and there are now lots of mathematicians who look very different. All of these people are great mathematicians, past and present. And they all are making big contributions in mathematics, but they don't all look like that first group of mathematicians that we saw. And again, the message here is that there is a place in mathematics for everyone who looks, no matter what you look like. So a couple other important mathematical points that I always like to make is that mathematics is a gatekeeper. So mathematics can give you opportunities or take opportunities away from you. And so you have to be very, very careful that even if there are parts of mathematics that you don't particularly enjoy, you have to recognize, for better or worse, and I would say arguably sometimes for worse, mathematics is, you're not going to graduate from high school without knowing mathematics. You're not going to graduate from college without knowing mathematics. And so you have to figure out how to learn the mathematics you have to learn, at the same time trying to find the mathematics that gives you joy, that you want to do, that you like to do, in ways that you can contribute. Another really interesting thing for me about mathematics is that a lot of mathematicians, I would argue even most mathematicians, work on one problem for their whole life. So I think sometimes we think math is just fast, and math isn't fast at all. If you go to a math department in a university, or you go to a place where people are solving problems using math, no one's working fast. Everybody's working slowly and methodically. And two characteristics that are really important when you're working on big mathematical problems are persistence. You can't give up. You have to keep working on the problem and working on the problem and working on the problem, because sometimes, even sometimes in the middle of the night when you're sleeping, you will wake up and something will come to you that you hadn't thought of during the day. The other thing is collaboration. This is so important because most big, important math problems, they don't get solved by one person. They're solved by many people. Sometimes people all over the world are working on the same problem, and then those people are coming together and figuring out how to solve those problems. Sometimes those problems are just mathematical, very pure mathematical problems. And other times they're very important problems like pandemics, right? Like solving problems like pandemics. So most importantly, everyone is a mathematician. Mathematics is everywhere and in every aspect of our lives, and there is a place in mathematics for everyone, including you.
I'm just kind of still wondering, base 27. I'm all the way back there in my head. So did you have to like learn base 27?
No, this is just one tribe. And you know, this is a very rural tribe, and you know, now most of the schools they're European, you know, they were a British colony and Australian colony, so the schools are in very traditional, you know, base 10, and most people in Papua New Guinea would use base 10 systems. This is just one particular tribe that, you know, Papua New Guinea is like this amazing I don't know, just so many little tribes that all have their own really very distinct culture. So this is just one. And this guy, Jeffrey Sachs, who's an American, he went to Papua New Guinea. He happened to hear about this tribe and went there and studied them. And there are videos online and everything of him working with the kids doing this, learning this system.
I've never heard of a base 27. That is really fascinating.
I would think that'd be kind of difficult for trade.
Yeah. Yes. Well, and this is the thing about Papua New Guinea. People often didn't really trade very much with even villages that were close, quite nearby. Traditionally, now of course that's not true. But anyway, that's all I have, and I don't know how long it was or if it was long enough or anything. But
oh no, that was perfect. I just loved, especially hearing this slide with all the different jobs related to mathematics. And I especially
love. I was going to ask what some of them were.
Yeah, me neither. Oh, me neither. I just just Googled it, and some of those, I mean, I wouldn't even be able to tell you what an operations research analyst does, but I'm sure it's important.
I love too the message, because I love math, but I am so slow at doing math problems. And I've always felt there was something wrong with me. Like maybe but then to hear you say that some mathematicians, not only do they work on one problem, you know, maybe for their whole career, but that they also are slow. And I tell you what, I'm persistent, I can keep at it, but I feel bad that I'm so slow at it. Like I remember in school being really young and doing math wars or what they call it, around the world or something. And I was always like they show you the math facts and I never could get past, like everybody was so much faster. I knew it.
Well, they shouldn't even have, I just can't believe we still do games like that just one person gets to finish feeling good. It's like the NCAA basketball tournament. Everyone ends in tears except one team, right? Yeah. So I don't understand why we still do those things. And my teachers, they'll say, you know, oh, I loved board races. I'm going to have my students do board races. I'm like, yeah, you loved it because you were good at it. But 99% of the students hate board races. They feel sick to their stomach when you even mention it.
So what would be so is it, I think it's to have students, you know, getting faster at those. Like right now I have a third grader and he's practicing his multiplication facts, right? But he's already been thinking about number sense and math facts in a completely different way than what I learned. Yet he still needs to kind of get there, like know with his math facts.
You still want to be fluent. You do.
So do you have any like alternatives to board races where the students could still work sort of collaboratively, but or I don't know, maybe that's too big of a question.
Well, no, I mean, I think collaboratively is the point for me, right? Mm-hmm. Because I think sadly schools in the United States and globally have been framed competitively, right? You're trying always to do better than the person next to you. And even when I talk to even very well-educated, very parents who I really respect, they still are wanting their Johnny to be number one, right? They still want Johnny to get through, you know, the most advanced calculus in high school. And I say, like, to what ends, right? At what costs? You know, now we're tracking kids in math at very young ages. So by third grade, sometimes you're already in the eagles and the dodos, and this is, it's damaging both to the kids who have been labeled as the dodos, and everyone knows how that works, right? But it's also not great for the eagles, because really in the end, collaboration's got to be the answer, right? That's how mathematics works in the world, but it's also how everything works in the world, right? It's how we're going to solve global problems. I mean, we have to be working together. We have to be helping one another. We have to be helping, taking joy, finding joy in helping someone else understand something, rather than taking joy in knowing I know something that they don't know, right? So it's like, I just think we have to turn it all on its head. Education as a competitive endeavor into a more collaborative endeavor. And sadly, our culture tends to lean toward being a competitive endeavor in general. So for our schools to try to turn that on its head without our culture also somewhat turning it on its head, I think is pretty challenging. But I think teachers can do a lot. I mean, I think there's a lot you can do in your own classroom to promote collaboration and to, help people see that winning is when everybody in your group can do the problem. And, so I think there's a lot to do. But I do agree with you, Sarah. We want students to be fluent. I mean, knowing your times tables is just really helpful, but it shouldn't define you. And it shouldn't be that if you can't do it fast, that you are told basically from, then third grade that you're not good in math, because that damage that we do in third grade, it never goes away. It never goes away. That child will always feel like they don't have a place in math. Instead of us trying to find those students' places, what are you good at? Some people are really fast in math facts, but aren't very good problem solvers and aren't very good collaborators and aren't very good abstract thinkers and whatever. So I think, helping students find their place seems like the most important thing.
I think that analogy with the track and field was so wonderful for that very reason. And I wonder if when I've heard students say, well, I'm not good at math, or, that feeling, I think you had mentioned that earlier with the Bulgarian students, that it's part of their culture that everyone can do math. I wonder if that might be influenced from things like board races. Or so, I don't know, maybe not, but yeah.
Well, right. I mean, I think that is,
yeah.
Bulgarians spend time board racing. Believe me, they're not doing that over there. And it's not that there's no competition. Of course, there's still competition. Right. I think it's, even in track and field, the fundamental idea is competition. But everybody gets a chance to show their, what they're good at,
Yeah.
Sorry.
Oh, wonderful. Well, gosh, Jill, we sure appreciate your time today meeting with us. And I think your message is absolutely wonderful. I'm so excited for people to see this.
Oh, well, thank you so much.